Hi guys, Terry here again. In this video I'm going to be working the question 6 of the July 2021 CSEC Maths paper 2. If you haven't done so as yet, please hit like and subscribe to my channel. Alright, so question 6 in this paper, you have two tetrahedral die, right? So you all may be accustomed playing board games, and normally we have 6 faces. But this is what we call a tetrahedral die, and we only have 4 faces in this case here. But you are basically, you have 2 of those, right? And the numbers obtained on the turn down face of each dice are noted. Create a sample space listing all the possible outcomes. So all we need to do here, guys, we need to put die 1 and die 2, right? In the case of die 1, right, we have 1, we can get a 1, we can get a 2, we can get a 3, and we can get a 4, right? So let's draw some lines here. So those are the possibilities for die 2. In the case of die 1, we also have the possibilities of getting a 1, 2, a 3, and a 4, right? So therefore, let me just draw. Right, so I'm trying to draw the sample space now. Right, so the possibilities are I can get a 1 and a 1, right? In this case here, I can get a 2 and a 1. I can get a 3 and a 1. I can get a 4 and a 1, right? And we do the same thing again here. This will be a 1 and a 2, 1 and a 3. This one is a 1 and a 4. So basically, I'm writing down all the different possibilities here, right? This one here will be 2, 2. This one will be 2 and a 3. This one will be 2 and a 4. This one will be 3 and a 2. You can get a 3 and a 3 in this instance. This one is a 3 and a 4. And this is 4, 2. This one is 4, 3. And this one here is 4 and a 4, right? So these are all the different possibilities here. So this is what we call the sample space. These are all the different outcomes if I were to roll these 2 dice, right? Now what do we want now? So that's part A. Now they said using your sample space now, created in A or otherwise, determine the probability of obtaining a 4 on both dice, right? So you want to get a 4 on both dice. Now how do we do that? Now if you want to get a 4 on both of them, right, the only place where we get a 4 on both of them is here, right? Now the total number in my sample space is, if you check all the possibilities, we have 4 by 4. We have 16 possibilities. So you have 16 outcomes, right? There's 16 possibilities that could take place, right? But only one of those possibilities I can get a 4 and a 4, right? So we can just say the probability, right? And this is getting a 4 on, right? So you want a 4 and a 4, right? So in this case here, it's going to be 1 over 16. So I can just look at the sample space and I can get that. Or we can say the probability of getting a 4 on die 1 is equal to 1 over 4. The probability of getting a 4 on die 2, right, is equal to the same a quarter, right? So if you want probability of a 4 and a 4, right, you need to get a 4 on both dice. It'll be a quarter multiplied by a quarter, which is 1 over 16. So you can use the sample space, or you can do a calculation like this. So that's 4 on both one. Now they want at least one, you want to get a 4 on at least one of them, right? So let's look at the sample space first of all. So the probability in this case here, right, and we want at least one. 1 4. Right? Now if you go, sorry, you know your total outcome is 16, right? So we want at least 1 4. So that is here, 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 and including this one here. So that is 1 2 3 4 5 6 7, right? So I'm getting 7 over 16 as my probability, right? So that, hopefully that makes sense to you all, right? But it is 7 over 16. Now I can do it as a calculation as well, right? So how we can do this? The probability of getting a 4, right, on die 1, we know that's 1 over 4. The probability of getting a 4 on die 2, right, is equal to a quarter as well, right? So here's what we want. We want the probability of at least 1 4. Right? Now here's how we can get that. We can either get a 4 and something else, right? So you can get a 4, right, on one of the dice, on the first die, say, and not a 4, right? Or you can get a probability of, the second option here will be not a 4 and then a 4. So you can get not a 4 and then you can get a 4, right? We have another possibility as well. We can get a 4 and a 4, right? Those are all my different possibilities there. So a 4 and not a 4 will be a quarter multiplied by 3 over 4. Plus, in this case here, it's going to be 3/4 multiplied by 1 over 4. Plus a quarter multiplied by a quarter. Hopefully that gives us 7 over 16. So this is going to be 3 over 16 plus 3 over 16, right, plus 1 over 16. And in this case here, I'm getting 3 and 3 6, I want 7 over 16. Right? So this is an alternative way to work the same thing, but the diagram is easier to work with. The next one here, we want exactly, you want to get a 4 on exactly one die, right? So you want to get it on exactly one die, right? So in this case here, go back to the diagram, right? So you want to get a 4 on exactly one die, right? So we know it should be out of 16, right? That's a total number of possibilities here. So we only want to get it on one die. So that is here, 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 and here. That's going to give me a total of 6 different possibilities, right? So this here is going to be 6 over 16. That's my answer, right? I could have done it like this as well. Probability of a 4 on exactly one die. Right? We can say you have to get a probability of a 4 and not a 4, right? Or you can get a probability of not a 4 and then a 4, right? Those are my possibilities here. So in this case, it'll be a quarter multiplied by 3/4 plus 3/4 multiplied by a quarter, in which case it'll be 3 over 16 plus 3 over 16, and you're going to get 6 over 16, right? So again, the diagram is the easier option to go with. And you want to show that obtaining a 4 on both dice are independent events, right? Okay, so we want to show that obtaining a 4 on both dice are independent events, right? So when you have a situation like this, right, and we're talking about independent events, right? So you can use a Venn diagram, and on a Venn diagram, so this is your first die, right? This is your second die. right? Now, in the intersection of those two, right? So you're getting a 4 on both die. So this here, right, represents a 4 on both of them, right? This one here represents a 4 on only one of them, right? On die 1, right? So this here represents a 4 on die 1, right? And this here represents a 4 on die 2. Now, if the events, so let's call the events, let's call event A, right? So event A, we're going to call that getting a 4 on die 1, right? Let's call that getting a 4 on die 1. Right? Let's call event B getting a 4 on die 2. Right? Now, the probability of that intersection there, right? For these things to be independent, this is what should be true. Probability of A multiplied by the probability of B. Right? So this is what we need to show. We need to show that the probability of A multiplied by B is basically equal to the intersection of both of them, right? Now, the probability of both of them getting a 4. Now, if you go back to your sample space, right? On the sample space, this here is the probability of both of them getting a 4. That's here, right? That's 1 over 16, right? So from the sample space, right, the probability of getting a 4 and a 4, right, is simply 1 over 16, right? So what we really need to do, we need to show that when I multiply these two probabilities, I do get 1 over 16. Now, P of A, probability of getting getting a 4 on the first die, right? So to get a 4 on the first die, it's going to be 1 over 4. To get a probability, or to get a 4 on the second die, it's going to be a quarter. So therefore, P A multiplied by PB, right, is a quarter multiplied by a quarter, which is 1 over 16. So you realize from your sample space you got 1 over 16, and from this you got 1 over 16. So therefore events A and B are independent events, right? So you just need to say therefore A and B are independent. Now the next part here, determine the probability of obtaining a 4 on both dice given that a 4 was obtained on at least one die, right? So this here, once we see the word given, right, we are looking for a conditional probability, right? So the probability of getting a 4, right, let A be the event of getting a 4 on both dice. So let A be the event, right, of getting a 4 on both dice, right? And we're going to let B be the event of getting a 4 on at least one dice, right? Now the probability of A given B, right, is a conditional probability. It's given by this formula, A intersect B all over the probability of B, right? So the probability of both of them, of getting a 4 on both of them, is 1 over 16, right? So this here is 1 over 16. That's the top part. And in the case of the probability of B, right, that is going to be, you can get that from the sample space, right? That was 7 over 16. Let's see, we got that somewhere here. I was here. Yeah, at least one, it was 7 over 16. So all we need to do is to divide this by 7 over 16, right? And that's going to give me 1 over 7. So that's my conditional probability here, right? Moving on to the next part. The scores of 30 students in a math test were used to draw a box plot, right? So you have a box plot here, or a box and whisker plot. The total possible score is 20. Use the box plot to calculate the median. So your median, right, is your Q2, and that's here. So all we need to do, we need to read off this here, right? And that's going to be 11. So your median here is simply 11. So that's part 1. Part 2, the range. All we need to do, we need to look at the highest score, which is 20, and the lowest score, which is 4. So this is going to be 20 minus 4, because the range is the difference between your highest and your lowest figure. So this is going to be 20 minus 4, which is 16, right? And the third part, we want the semi-interquartile range. So to do that, we need to record or measure what is Q1, and we need to measure what is Q3, right? Now, from our diagram here, 1 is, I should be around what, 7, right? The diagram kind of slanted here, so right, so you get around 7, right? So Q1 from the diagram is going to be 7, and we need to measure what is Q3, your upper quartile. Upper quartile looks like it's around 17, so we want semi-interquartile range, which is given by a half your upper quartile minus your lower quartile. So this is going to be a half multiplied by 17 minus 7. So 17 minus 7 is 10, half of 10. Your semi-interquartile range should be 5, right? That's your semi-interquartile range. Now we need to comment on the shape of the distribution for the next part, right? So they said comment on the shape of the distribution. Now what we can do, we can find the difference between, let's say, Q3 and Q2, which is 17 minus 11, which is 6, and we can find the difference between Q2 and Q1, and that is going to be 11 minus, how much it was, 7, minus 7, which is going to give me 4. So what we can say here is that since Q3 minus Q2, right, is greater than Q2 minus Q1, right, and the data is positively skewed, right? That's all we need to say here, right? The data is positively skewed. Right, and we just have one more piece here. I realized I didn't put it in the give me a sec, right? Right, so a student wants to determine the mean score of the set of data. State one reason why it would be impossible to determine the mean from the box plot. Well, we can't determine mean from the box plot because we need individual scores in order for us to determine the mean, right? So individual scores are required, right? right? Remember, mean or x bar is given by sigma x over n. I need this. I need the individual scores in order for me to do that, right? State what additional information would be needed to determine the mean score, right? So the additional information we require here is the individual scores. Right? And the last part now, they told us that the sum, given that the sum of the 30 scores in the class is, so therefore sigma x is equal to 354. We have 30 students here, right? Or 30 scores, right? And what else we have here? The sum of the squares of the scores. So we have sigma x squared is equal to 4994, right? So what we can do, and they want the standard deviation. So first thing we need to do, we need to find the mean, which is sigma x over n. In this case here is 354 over 30. That's going to give me 11.8. So that's my mean, 11.8, right? Now we want to get our standard deviation, right? So again, we have a formula for that as well. So that formula is simply, so standard deviation right is equal to sigma x squared over n minus x bar squared, and we find the square root of that. That's our formula for standard deviation. So sigma x squared over n is going to be 4994 divided by, in this case we have 30 scores, minus your mean squared, which is 11.8 squared, and you find the square root here, right? And that's going to give me, let's see, 4994 divided by 30 equal minus 11.8 squared, and I am getting 27 point, is that correct? Oh no, sorry, I have to find the square root as well, right? I forgot the square root. Yeah, and that's going to give me about 5.22. So this here is 5.22, right? So that's my standard deviation there. So I'm making use of this formula in order to work out my standard deviation, right? All right, guys, so please hit subscribe and like. And for maths, maths, chemistry, and physics online classes, you can send me a WhatsApp at this number, right? Take care, guys.